Okay, so we're going to look at problem 5119. It's a homework problem. It's one of these problems that can be made to be quite difficult, or it can actually be pretty straightforward if you can visualize what's going on a little bit better. So here's the problem is given. It says a bronze bushing is mounted inside a steel sleeve. Knowing that the specific weight of the bronze is 0.318 pounds per cubic inch and the steel is 0.284 pounds per cubic inch, determine the location of the center of gravity of the assembly. Okay, so this is coming over here. I spent a second on SolidWorks to put this together, so hopefully this makes it a little more clear. What we're dealing with is something like this. You have this inner part, which is bronze, encapsulated or inside this outer part, which is steel. Okay, so you can see on the bottom, it's all one big thing. It's one bronze sleeve that goes through the whole thing, and steel on the outside. So we're trying to find the center mass. So obviously, if this part wasn't here, it'd just be right in the middle, right? You'd come in here, it'd be 1 inch to 1.4 inches tall, so it'd be at 0.7, right? But we're putting this big heavy thing on the bottom, so that's obviously going to bring the center mass down. So let's talk about how we're going to find what that is. And the way we're going to do this is we're going to come over here and we're going to break this into 3 parts. I'm going to draw a line, straight down here. I'm doing this with my mouse instead of the pencil, so it's a little bit, wow, I can't draw straight. So we have this part right here. Again, looking over here, let's have this section right here that goes all the way through the whole thing. We have this one right here, which we're going to consider body 1. This we'll consider body 2. And then this outer section, or this ring around the outer edge, is going to be body 3. So let's see if we can write this. This is 1, this is 2, and this is 3. Okay, so then let's come over here and let's do this in Excel because it'll make life much easier. So I already set this up a little bit, cheated, sorry. Let's go through and put in the information that we need. So body 1, this is just the bronze thing. What is the Y bar? Well, it's 1.4 inches tall, so it's half of that, so 0.7. Okay, what is the Y bar of body 2? Now again, this is the outer one, not including this section, so it's just this full length, so again, it is 0.7. And body 3 is this little donut that's out here at the outer edge, and it is 0.2, so it's half of 0.4, so it's 0.2. Okay, now, you'll notice here I put volume and gamma. We don't need these. I mean, we're going to need them in order to calculate weight, but we don't need them directly. We're not going to use them directly, but we're going to use them to figure out the other stuff, right? Because when all is said and done, what is Y bar? So just like these other times when we did Y bar Y bar is sum of Y bar area divided by area. Well, this is in 3D and it has different masses or different densities. So because it has different densities, Y bar is going to end up being the sum of the Y bar times the weight divided by the weight. Okay, so we have to figure out the weight of each one of these things, and so let's figure it out. So the volume times gamma, so the volume, which is pounds or cubic inches, times the pounds per cubic inch is going to give you weight, right? So what is the volume of 1? Well, it's the volume of this outer one minus the volume of this inner one. You could go through and do the math, and you'll find that it works out to be it's pi r squared. It's pi r squared the area times the height, so pi r squared h of the outer one minus pi r squared h of the inner one. Since we're dealing in diameters, it's going to be pi over 4 times diameter squared, and it works out to be the diameter of the outer one squared, so 0.75 squared minus 0.5 squared. So that is, oh yep, and let's do this right. We have to say this is equal to, and to call pi in Excel, you have to do it like that. So there we go. So the volume of this one is pi outer diameter squared minus inner diameter squared over 4. Okay, and what is the volume of this one? It's the same thing. I'm actually just going to copy this down. Oops. I'm going to copy this down to here. Oh, and that's not quite complete. That's the area, and it needs to be times the height. So times 1.4, right? Okay, so that is the volume. Sorry about that. This one is going to be the same thing, but now the outer diameter is this 1.125 because we're dealing with body 2, and the inner diameter is 0.75. So this is 1.125, this is 0.75, 0.75, and it's still the same height of the 1.4. So boom, there's the volume of that. And the last one is this portion. So this is the same basic idea, right? Except for now we're going from 1.125 to 1.8. So this is 1.8 quantity squared minus 1.125. And now this time it is only, sorry, I don't know why I keep saying that. It's only this height right here. So it's times 0.4. So those are the volumes. Again, we don't really care about the volumes. What we actually care about is the mass. And so let's put in the specific weight. Coming here, the specific weight of 1 is 0.318. The specific weight of steel, which is bodies 2 and 3, is 0.284 and 0.284. So therefore the weight is equal to the volume times the specific weight. And we can just copy those down. Really wish I wouldn't do that last one. Okay. And then the y bar times weight is literally this y bar times this weight value. So this is equal to y bar times weight. And carry that down. And then now we need to look at the sums. So the sum of this one, let's see if I can get that, there we go. Is, well, we don't really care about the sum of the volume. What we really care about are these two right here. Boom. And y bar is what? Well, when all is said and done, it's equal to the y bar times weight divided by the sum of the weight, which is 0.5255885. So this makes it look way easier than it probably really is, right? Because there's a lot of stuff going on in here that we just kind of glossed over. But the idea, hopefully, is pretty straightforward. The idea is that you have to consider the weight of each body, so bodies 1, 2, and 3. You can consider the y bar times the weight, and then it's just like the 2D, just like the homogeneous stuff, is the y bar, sum of y bar times weight divided by the sum of the weight. And it gives you 0.5255. And then sanity check, does that make sense? So again, if this piece was not here, it'd be 0.7. But this piece is a pretty big chunk of the thing, so you're looking at about 0.526 inches. So it seems to pass. There we go.